Okay, now we have a trinomial, and it has coefficient of 1, and the last number is 64. 64, if you remember, is a perfect square. So the first part is still simple here, but 164, 2, 32, 4, 16, 8, and 8. This time around, we got a middle term, unlike the difference of square where we don't have. But this square is positive. So that means both of them have the same sign. It's also positive. That means everything has to be positive factors here. If you notice, this is 2 times 8. This is 8 squared. Then 8 plus 8 equals 16. So this way we can factor pretty quickly and go, oh, it will be a squared plus 8a plus 8a plus 64. And you see that the first pair has a, second pair has 8. So you go a plus 8, and then a plus 8. And then after you factor, you have 2 identical binomial brackets. A plus 8 times a plus 8. So you can rewrite it as a plus 8 all squared, because we have 2 of the brackets. So this is called a binomial square. Another example that we can use is, what happens when is x squared minus 10x plus 25. So the pattern here is, this is a square number. In this case is 5 squared. And here is minus 2 times 5. And this matters because we're always looking for this pattern of 1, 25, and then 5 and 5. You go through the regular method. This is a minus, so therefore everything has to be negative, right? Positive product, negative sum, therefore everything has to be negative, all the factors. And because we know it's 2 times negative 5, we don't even need to check this and go right here for the negative 5 and negative 5. Minus 5 is minus 10, of course. So we can just go x minus 5, x minus 5. Because both of them has this. And this is x minus 5 all squared. So in general, when we have a pattern where is a number square minus, or plus actually, we'll go for that another one as well, 2 times a and then times b plus b squared, we can take this and go, well, what is minus 2ab? Minus 2ab means 2 copies of this. It's minus ab. And then here go minus ab plus b squared. And then this has common factor of a. And then you go a minus b. But this doesn't have minus b, except when you factor out negative b. Then you also have a minus b. And then the common factor of a minus b for both of them becomes a minus b, which is a minus b all squared. So there, and as I've said, there's a positive version, which we go a squared plus 2ab plus b squared, and this equals a squared plus ab plus ab plus b squared. This is a little bit easier to factor because all you need is common factor here. These two terms is a, common factor here is b, and you got the bracket a plus b. So what good does this do? These two statements, if you skip all the stuff in the middle, also known as identities. That means this statement from here to here is always true as long as a and b is some real number. So that means we can use this pattern to help us factor very quickly later on. X squared plus 14x plus 49. With this pattern, you can see that this is a plus, this is a plus, this is a square, 7 squared, right? 7 squared, and this is 2 times 7 times x. And this is x squared. So this follows this pattern here. So the first term is just x, and then this is a plus because this middle term is a plus, and then the 7 all square. So that allows you to factor very quickly.